What is going on, guys? Welcome back. In this video today we're going to build something super interesting, super useful, and you're going to learn a lot by implementing this. We're going to implement a customizable soundboard for Linux, which means we're going to have an application where you can prepare some sound files, then you can switch back and forth and you can just play them through the same microphone that you're using for recording, for Discord, for whatever you're doing. In video games, you can just play sounds through the same microphone by using keyboard shortcuts. Now, I'm not entirely sure if this works, but I now changed also the microphone in OBS. So right now, if I press the button, you should be able to hear the beep sound. I think you heard it. I saw some spike. And then I can also stop it, as you can see. Now, this involves a couple of challenges, so you're going to learn a lot by doing this, because on the one hand, we need to handle pulse audio, we need to set up a sync, we need to set up a virtual microphone, we need to loop back the sound of our physical microphone into that sync, we need to handle permissions, especially when it comes to the input device, and we also need to handle shortcuts on Wayland. So as I said, you can learn a lot today, especially if you're interested in these lower level aspects of programming in Linux. If you like this video, let me know by hitting a like button and subscribing, but now let us get right into it. Alright, so I think this is going to be a super interesting project today. We're going to build a fully customizable soundboard for Linux, which means we're going to be able to use keyboard shortcuts to play sounds in various applications, Discord, video games, recording tools like OBS or Audacity. And we can do all of this in Python, but we're mainly going to use Linux command line tools in an automated way via Python. So the main tool that we're going to use here is called PACTL. And that is part of Pulse Audio. Pulse Audio is the sound server that we're going to do all of this with. And the PACTL tool is the command line tool that allows us to see all the microphones, to see all the syncs, to load modules, to see modules and all that. And we're going to mainly use Python to automate various commands here. And Python is just going to be a terminal user interface around this, so to say. Now, in order to get right into it, let's briefly talk about the different commands that we're going to use. Not all of them yet. We're going to just look at the basic ones. Three commands that we're going to use are PACTL list short. And then the three things are syncs, sources, and modules. And in order to understand what the difference here is, we're not going to talk about every single thing here, but the sync is basically like a collector of stuff. You have different sounds, like the microphone sound, like the sound that we're going to play using the software, and the sync basically centralizes it, collects it into one thing, if you want to call it that. Then sources are microphones. So this right here is my Rode Pod mic, this thing that you're seeing here, that is a source. But a source can also be a virtual microphone. Why is a source important? Because that is the thing that you can select in Discord, in Counter-Strike, wherever you're using this microphone. This source is the thing that you access, that you select as an input device. And then you have modules. These can be different things. We're going to use this for loopbacks, which means that we're going to use a loopback module to get the sound from the microphone into the sync, to basically mirror it, to send it there. That's the basic idea. So we're going to have a sync. The sync is going to collect all the stuff. The microphone will be looped back into the sync, and the source is just going to monitor the sync so that we get a microphone that has the same sound that is present in the sync. I hope this was not too confusing. And as I said, we're going to automate all of this in Python. So let's get right into it. We're going to navigate to our working directory. In my case, the tutorial directory here. I'm going to say UV init to create a new UV project. You don't have to do that. You can also work with pip and requirements.txt if you want to. I prefer using this Rust-based Python package manager. And I'm going to go into main py and delete everything we have here. And we're going to start with a very simple import, which is subprocess. Subprocess is basically just allowing us to run Linux commands. So what I want to know first is, do I already have a virtual mic? Because if I run the script multiple times, I don't want to create the same microphone, the same loopback and everything from scratch. So what I'm going to do is I'm going to say syncs is equal to subprocess and then check output. Here now we can provide a list of command parts, I would say. PACTL list, and then the same thing that we used in the terminal, short syncs. Now we also want to add here a keyword argument, which is text is equal to true. Then we want to strip everything from here and we want to say split lines. So every line is one sync. And then we want to do the exact same thing for the sources and also for the modules. Just that we have to replace your syncs and here as well. In addition to that, we also want to define a name, or we want to specify a name for our sync and for our source. So I'm going to say here, sync name is going to be virtual mic sync, and then source name is just going to be virtual mic. This is important because we're always going to use the same name. So if this name already occurs, we know that we don't have to set up everything from scratch here. So I can say if any, or actually I should negate this, if not any. And now I want to iterate over the syncs and see if the syncs contain, the list of syncs contains a sync with this name. So to understand what we're doing here, we can run this again, pactl list short syncs, and you can see that this is going to be tab separated. So that is index 0, that is index 1. We want to make sure that the index 1 thing here doesn't have the name virtual mic sync. So we're going to say list comprehension s dot split on tab, so \t. The first item is not equal to, or actually I should say is equal to sync name, because we're negating this here, for s in syncs. So this should basically return, this should actually trigger if we don't have a sync that has the name. So if virtual mic sync does not exist, we're going to go into this if statement here. Otherwise, we're going to skip it. And now the command that we're going to run in this case, if we don't have the sync set up, is the command that actually sets the sync up. And for this, I need to actually look at my second screen because I don't know it off the top of my head. But we're going to do subprocess run, and we're going to do pactl, and then load module null sync. And then we need to provide the sync name. I'm going to use an F string for that. Sync underscore name is going to be the sync name that we chose. So next time when we run this check, it's going to already be there. So it's not going to go into this if statement. And then we're going to say sync underscore properties is equal to device.description, and then is equal to virtual mic. That is going to be the name of the device, the description. So what we do here is we check, does this sync already exist? If not, we create it. It's as simple as it gets, right? So the next thing is we want to do the same thing for the virtual mic source. So actually we can even copy this and we can paste it down here. The difference here is that we say is equal to source name, and we need to say for s in sources. Besides that, we don't say module null sync, we say module remap source, and it's also not the sync name, it's going to be master is equal to, and then we need to use sync name again dot monitor, because again, this is just going to monitor, this is just going to mimic, to mirror, so to say, what is in the sync. And after that, we want to also set the source name, which is going to be source underscore name is equal to source name that we specified as a constant. And I think the properties command is the same, so we can keep it. So what we're doing here is we're checking, does the source exist? Does the virtual mic exist as a microphone, as a source, as an input source? If not, create it. Now, the next thing we want to do is we want to give the user the option to choose a microphone. So we want to say, look, these are all the sources that you have. Which one do you actually want to loop back into the sync? So which of these microphones or sources that I have available here do you want to use to feed into the sync? But first of all, of course, I want to check that there is not already a loop back into the sync. So I cannot use two microphones, and I can also not use the same microphone twice. And for this, we're going to look at modules. So let's run this command again, pactl list short modules. And in this case, what we would see here, we don't see it right now, is we would see something called module loopback. So all we want to do here is we want to see if module loopback exists with this sync name. So do we have a line that contains virtual mic sync and also module loopback? If yes, then we're going to not set this up. Otherwise, we're going to allow the user to choose from a list of available sources. So for this, I'm going to say if the length, so we want to check if there's anything in there. So if this is greater than 0, if the length of the list comprehension L for L in modules, and the condition, as I said, is that we have module loop back in L, and L is going to be a line. So we have the module lines. We have one line that contains module loopback, and we also want to know, does this line also contain the sync name? So if this and also sync name is equal to sync name, that is going to be an F string again. So if that is also part of L, then we know that this is a problem. We don't have to do it again, or it's not a problem. Just we cannot allow the user to select a microphone again. So if this length here is 0, in this case, we don't have such a module, then we can go and allow the user to choose. So that is going to be our condition. Now, the available microphones for this should be only the microphones or the sources that are not the sync or the source that we just created above. So we're going to say here available mics is equal to split. Again, use the tab for splitting. And we want to make sure that so it's gonna be the name of the source. It's gonna be the name of the microphone that we also checked for here. For S in sources, but only if this value, if this name, so if split again by tab and then index 1, if that is not in and it's not allowed to be the sync name or the source name, or actually to be precise, it should be the sync name monitor, I think. So it should be an F string here, which is going to be using sync name and then dot monitor. So that should not be the source that we choose here. These are the available microphones. And then we can print a simple menu. I can just say \n join, and then we can do a list comprehension here of F strings, where I'm going to say I want to have I plus 1 dash, and then I'm going to have the microphone name. So that's going to be M, or actually since I'm using I have to say available mics I. And that's just going to list all the microphones. So I need to say here for I in range length available microphones. So we're using +1 here to start counting with 1. And then we just iterate over that, and we're going to allow the user to make a choice. So choice is going to be input, select the microphone to connect. We're going to also naively just typecast this into an integer without any checks for the sake of simplicity here. And then we're going to say chosen microphone, or actually maybe we should say if choice is less than or equal to available mics. So the length of available mics, in this case, we can say chosen mic is going to be available mics. And now be careful. You don't want to go with choice because choice is going to be 1, 2, 3, 4, 5. You want to start counting 0. So we need to subtract 1 again since we added 1 here. And then we have the next fancy command, which is just going to be pactl again, subprocess dot run. And we're going to run the command for the loopback. So I'm going to say pactl. And what was it? It was load module again. And module dash loopback. That's going to be the source. So the source that we want to loop back is going to be our chosen microphone. That's going to be the title of that. And the sync that we want to loop this back into is going to be sync equals to sync name, the one that we created. And then we're going to add the argument here that latency msec equals 10. So that's just going to mean our microphone that we chose from the list is going to now feed its sound into the sync, so that we don't just have the sounds that we play with the soundboard, we also have the voice when we're in Discord, for example. All right, so that's actually the setup. Let's see if this already works. So how can we see that? We can say pactl list short and then all the stuff like sources and syncs and modules, and we don't have anything here, so we don't have any virtual microphone or something. Then I can say uv run main.py. Now you can see I get here the selection. Which microphone do I want to use? I'm going to go with 4, and then there you go, it's done. Let's run the commands again. Now I have the virtual mic, and I also have the sync, and I should also have the module with the loopback. There you go. So also now if I run this uv run main.py, Okay, this doesn't work because it still tries to select a microphone. That's not good. It should recognize that it's already selected. And the reason for that is because I'm looking for sync name here. It should just be sync. There you go. Now it does nothing. Now it just accepts that we already set up everything. Perfect. So this works. The next thing we need to do is we need to play sound, but we also need to play sound depending on inputs. So this now gets a little bit tricky because we need to access whatever happens on the keyboard, and we need to access that on a kernel level. So we need to get the, at least I think it's on a kernel level. We use a package called fdef. I'm not even sure what it stands for, but essentially you need to get the events, and you cannot get the events without sudo privileges unless you give the privileges to a user group and then you assign yourself to the user group. That is possible because you cannot just run this with sudo, because Pulse Audio needs access to the user session. So this gets a bit complicated, but essentially what we're doing now is we're going to connect to our keyboard here. We're going to listen to the keyboard events. For this, we need special privileges. And in order to get these special privileges, I have a list of commands that we're going to type in now. So I already did this on my system, which is why it works. But essentially what I did is I ran sudo usermod and then -ag input and then the user, so the username. That assigns the group input to me. And then what I did is I created a rule, a udef rule, basically, that says that I have access to all the input devices, which isn't necessarily a secure thing to do. I would not recommend this long term. I will probably find a better way long term to do this because I'm actually working on this as a side project. It's not just for the tutorial. So in later versions, probably there's going to be a cleaner solution, let's say. But yeah, so basically I ran the usermod command and then this command here. So you will find this on my GitHub. I will leave a link with the code. And this basically now sets up a rule that allows us to access the events of the different input devices. This is now very general, so it allows access to all the input devices that have events. But that's the quick fix to do this. You can also reverse this, of course. And as I said, this is not the professional way necessarily to do this, but it's one way to get access to what you're actually doing. And it also works on Wayland. So once you've done this, you can go back into main py and we can start reacting to keyboard shortcuts. So before we pay attention to any of the sound stuff, let's just go down here and see if we can get print messages by pressing keys. So I'm going to say here keyboard def for keyboard device is going to be equal to, and now we need to actually do an import here, which is going to be from fdef import, so event device. I think it stands for event device. This would make sense. So from fdef, whatever it stands for, we're going to say input device. We're also going to import categorize and ecodes. And for this to actually work, we need to also add this to our project. So uv add fdef like this. And then we can also do source vn bin activate to get the auto completion in neovin. All right, so down here I can say keyboard device is equal to input device, and then I need to provide the path to my input device. How do I find this? I can just go here and say ls def input and then by ID, and here you can see all my input devices. And the one I'm interested in is the keyboard. Obviously I have the Keychron K6 Pro, and the one that I'm interested in, as I said, is here the event KBD. This is the thing that will give me the keyboard. And the keyboard events. So actually I can copy this here and I can just say the input device is def input by ID and then this here. So, and then what we can do is we can say super is being held. That's going to be false by default. The idea is I want to use the keyboard shortcut super and then the opening square bracket to go back in the list of sounds, the closing square bracket to go further or next in the list of sounds, and then the apostrophe or single quotation to play the sound, and then maybe the semicolon to stop playing the sound. So we're going to say here for event in keyboard def read loop. That is going to allow us to get the events here. If the event type is equal to ecodes.event key, I'm going to say key event is going to be equal to categorize event. And now at this point, you just need to know what the events are named. So you need to know what the codes are for the buttons. So we're going to say, first of all, here, if the key event dot key code, if that is equal to, and now we're listening for the super key. So I'm going to say here, key underscore left meta is the key identifier here for the super key or the command key or whatever you want to call it. If this happens, I want to know, or I want to set super held equal to true. So I'm going to say here, super held is going to be equal to event dot value in 1 or 2. So 1 is for it being pressed, 2 is for it being held. If one of the two is happening at the same time as something else, we want to set super held is equal to true. And otherwise, we're going to set it to, so if the event is, for example, that we're not pressing it, but that we're releasing it, we want to set it to false, which is automatically going to be happening by the in, or by using the in operator. So that is for the super key. Now, if we also press the opening bracket, or it's called the left brace, then we're going to trigger one print message. And for now, it's just going to be a print message. Later on, we're going to actually do something with the sounds. So I'm going to say here, elif key event, and then key code is equal to key underscore left brace. If that is true, and the event dot value is 1, so it's actually pressed, it's not released. And we also have super held. So if all these three conditions are true, which means super is pressed, the left brace is pressed, and it's happening at the same time, then we want to print, let's say 1, just so we know that it's actually happening. Then I can do the same thing here with the right brace. And for this, I'm going to print 2. And then finally, or not finally, we can do this actually 2 more times. One is going to be the apostrophe. That is going to be the single quotation basically for playing sound, or actually let's say 3 for now. And then we're going to have the semicolon for stopping the sound. So these are the events, and we're going to add functionality to them here in a second. Now, one thing that I didn't mention, when you do the permissions, when you actually set up the user group and everything, you need to log out and log in back into the system. Otherwise, it's not going to be applied. I already did this before the video. So in my case here, if I didn't make any other mistakes, I should be able to just run this. And now, even if I go to some other window like this one here, and I start using super and left bracket, you can see I get 1. And then here I get 2. And then here I get nothing. Okay, apostrophe doesn't seem to work, but semicolon works. Probably I misspelled it. Let's see. Yeah, because maybe I'm even mispronouncing it. I'm not sure. Not a native speaker. So yeah, an E was missing. So in this case now, it should work as well. Perfect. And then we almost have it. The only thing left to do is to actually do something with the sounds. For this, we're going to need 2 more packages. Actually, let me first install them. UV add sound device and sound file. And we're going to go into main. And here we're going to say import sound file as SF, import sound device as SD, import OS. And I also want to have here, first of all, my sound files. So sound files is going to be equal to OS, or actually it's going to be S for S in OS list dir sounds. And I'm going to say current selection is equal to 0. So when I press the left one here, I want to say selected, and then the sound files that I have available here, and index current selection. Actually, the same thing should happen here, but the difference is I want to say here current selection should be equal to the current selection -1, and that modulo the length of the sound files list, so that we actually can go in circles. The same thing here for the right brace, just with addition, and then actually that's it. Now, one thing that we need to do, I actually forgot to add that up here, we need to actually get the device into, or we need to actually select the device with sound device. Now, there is one thing here that might be a bit odd if you're running this for the first time, everything from top to bottom, which is that sound device here, when you import it, loads stuff and recognizes stuff. Now, if you import it here, and then you create stuff here, and then you try to use it down here, it's going to say it doesn't find it. So what you need to do to actually find the new modules and everything, and the source and everything, you need to say sd._terminate, and then sd_initialize. This is just going to basically reinitialize it so it can find the device. And then what we're interested in here is we want to find the device, which is going to be the result of a list comprehension, then selecting the first element. It's going to be D for D in SD query devices. And we want to only look at those devices that have more than 0 output channels and that have the name virtual mic. So it's going to be if D and then max output channels, that has to be greater than 0, and also the name of D has to be exactly equal to virtual mic. And if for some reason this looks differently on your system, you can just print the output of query devices and see maybe in your case it doesn't have the name virtual mic. Maybe you want to say virtual mic in D name or something like this to make it easier. So that is going to give me the devices. I want to get the first entry here if there are multiple, and now I have the device selected. Otherwise, if there is an index error because it didn't find anything, we can say print no device found, and we can exit the script. Maybe with code 1. All right, so we have the device now. The only thing left to do is we need to play the sound. And for this, we need to go in here. We need to say played sound files, current selection, just so we know that this actually happened. And or actually, maybe let's do it first. Let's say playing and then do it below. I'm going to say here data and sample rate are going to be equal to SF, which is sound file, read, and then OS path join sounds with the file. So with sound files current selection. And I think we need one more closing bracket. Now to play this, we say SD play. We provide the data. We provide a sample rate. And for the device, we provide device index. And down here, we can just say stopped, whatever, and SD stop. So let's actually see if this works or if we get any problems. UV run main.py. Sounds, I think. Oh yeah, I don't have the directory sounds, of course. So we need to actually create a directory with sounds. And I already copied here 2 sounds. It's basically the same sound twice, and it's an artificial beep sound. And actually I copied it into the wrong directory. So let's say everything.wav has to be copied or actually moved. Everything.wav has to be moved to sounds. And it's basically the same beep sound. It's just for testing purposes, main py. Okay, so nothing happens right now. And I also, for recording, don't use this microphone, so you're not going to hear it here. But if I now try to do something, you can see I changed my selection here. I can also play it. I can also stop it. And we can actually see that this works by opening up Audacity. So here I can actually go and say audio setup, recording device. I can select the virtual mic here. So that is the thing that I can use as an input. And when I talk now, you can see that this is actually recording my voice. As you can see, when I talk, there is something. And now in this application, even I can say all these keyboard shortcuts still work while I'm focusing on Audacity. And then I can just play them. And you can see there's sound. You cannot hear it because I don't have the desktop audio available. And I also don't hear it because I'm recording right now. But these segments that you saw here, these were the beep sound. Now, I'm not entirely sure if this works, but I now changed also the microphone in OBS. So right now, if I press the button, you should be able to hear the beep sound. I think you heard it. I saw some spike. And then I can also stop it, as you can see. So yeah, of course, there's a lot more stuff to customize here. You can also do a keyboard selection here instead of hard coding this. You can also find a better way to give you permission to actually use it. We can build a TUI around this, and I'm actually probably gonna do it because on my GitHub here, I have a repository, Sound by the way, which is what this project will be. I still have here a vibe-coded version that uses PyQt, so we actually have buttons instead of shortcuts. But it basically works with the same principle. I didn't write this code myself for the most part. I understood the commands, understood the principle, but then I used Claude to basically code this. And I'm going to probably transition this to a TUI application where we can just use shortcuts. And I think this is a cool project, so if you want to follow that, you can watch this repository. But yeah, this is how you build a soundboard, a customizable soundboard for Linux. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, in case you're interested, on my website, you will find a tutoring and a services tab. There you can see what I have to offer if you need some consultation, if you need some help with a project from a freelancer, if you need some one-on-one tutoring, you can contact me there via email or LinkedIn. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching, see you in the next video, and bye.